Thank you to everyone who is here for their second, third, or second or third time, or even their first time. We appreciate having you here. It's really great. Uh, oops, got it. Okay. So, whoops, boy, I'm really trying to get through this fast this morning. I'd like to do the land acknowledgement. We acknowledge that we here in Alberta are on the traditional territories of many First Nations, Métis, and Inuit peoples who have lived and gathered on these lands for centuries. We are grateful for the opportunity to live, work, and create on this land. The agenda for today, it's a very short agenda. It's just about the use of manipulatives, and we will do a few tasks for fraction support using manipulatives. And the two manipulatives we will use today are pattern blocks, and we will also use Cuisenaire rods. Two of my absolute favorite manipulatives for fractions. And so, do you remember this slide from Monday? Those of us that were here on Monday? And the question was, when you think of teaching math, now we're talking in the fall, now we're talking starting in just probably less than a week, some of you start in 2 weeks, where would you place yourself now? Some of you did put yourself at 1 and 2 on Monday, and then there's others that put yourself at 3, 4, and 5, which was awesome. I would like you to think about that now, and in the chat, we're going to do the waterfall again. So don't press enter yet. Think about it. Where would you put yourself? Are you a 1 still, where you're like, oh yeah, I have no idea what's going on. I'm scared. Like, this is crazy. I don't know what to do. Number 2 is, okay, I'm sweating, but I'm scared. I'm not sure what's happening. Number 3 is, well, I'm on the fence. Like, I'm neither really scared, but I'm not really excited about this. Where number 4 is, I'm excited to get going. Everything is pretty good. I'm aware of things. And number 5 is chill. I've got this, baby. So put your number into the chat and go. Okay, hopefully I can give you some real working examples today for one topic, and Michelle, and mostly not sure about bridging. I totally get it, Christine. Yeah, we did not touch bridging, but you need to know that there are sessions coming up that are talking about bridging. Carol, great to see you have a better understanding between math and numeracy. Yeah, the thing is, like I said yesterday or the day before, numeracy is a really misunderstood term. A lot of people use the term to equal the definition of math. And there's, like, as we saw on Tuesday, there really is a difference between math and numeracy. Well, we have a lot less people at 1 and 2. We do still have some people at 1 and 2. We don't have any 1s, which is awesome. We have a lot more people at 3. I'm on the fence on this one, and you're neither really afraid, but you're not excited either. And we get that, because one of the things I think all of us that have been presenting to you really understand is this year is going to be a different year. It's going to be a tough year. There's a lot of bridging to do. The grade 4, 5, and 6 curriculum, especially the grade 6 curriculum, is pretty stacked up with new outcomes that students will not be ready for. So there's a lot of bridging that's going to have to happen. But oh, I'm thinking, what am I supposed to rename here? I get it. So Yeah, you're right, Jackie. If you could please rename your screen with your first name and the initial of your last name, that would be awesome. And if you don't know how to do that, just go to your screen and where there's the participant list or wherever, and you'll find the three dots or more. And you just click on the three dots or on more and just you'll find where it says rename. Yeah, it does help us with, especially when we're going to be going into our breakout rooms today. So that could be another reason people didn't show up today, Jackie. People might be scared of going into a breakout room and saying, oh, like, I'm not ready for this. But you know, one of the things that I really want you to be aware of is that there's so much research being done, and that is done in that we learn by making mistakes. We learn by our mistakes. If we don't make mistakes, we're not learning anything. And so we want to know where we're making those mistakes and what the mistake was so that we continue to learn. And so really important that we also instill that in our students, that it's okay to make mistakes. We really want to make sure that our kids are aware that we value their mistakes. Valuing mistakes is huge because that's where growth in learning happens. So today, like I said, we'll be talking about manipulatives. And what are manipulatives? Well, manipulatives are anything that we use that we can manipulate with our hands, that we can move around, that we can change the direction of them, that we can turn them, that we can do any kind of transformation with them. Those are manipulatives. Manipulatives are the concrete objects that we will use in our classrooms to help students understand the math. Now, in our last curriculum, I think you know that in our outcomes, a lot of them said kids will understand to do them concretely, pictorially, and symbolically. So the difference between concretely and pictorially is exactly what the words mean. Concrete is something that we can touch, move, etc. Pictorially is something that we see. Now, when we are doing things virtually, like today, we're still using manipulatives, because the difference between that manipulative on the screen that we're going to be moving around and a picture of it, this is a picture. I'm showing you a visual of what manipulatives are. But when you're going to be on the screen, when you're going to be actually moving these manipulatives around and turning them and changing direction and using them, that you're still manipulating the actual object. So that there are virtual manipulatives, and there are actually the hard copy of manipulatives that we use in our classrooms. Personally, I don't know if it's because I'm an old lady, I love the manipulatives, the concrete in classrooms. I have three daughters, and they're young adults, like I said, and my youngest, who's how old is she, Larissa? 24. She's 24, and she still says she prefers using the virtual manipulatives. She goes, like, it's new school for her. It's like the old stuff, the old school is the hard thing. So all kids are different, whereas my other one said no, she would rather use the actual manipulatives in the classroom. Okay, so why do we want to use them? Well, we want to use manipulatives in our classroom to build understanding. That's the bottom line. Understanding is super, super important for this manipulative. Those are in our cusps. And so when we're learning for understanding, we use the concrete manipulatives. We use the pictorial in our worksheets, from our textbooks, from the virtual resources that we'll be using. Those are the pictorial. But when we mix that with the symbolic, and that's the digits, when kids can actually manipulate the digits and do the math on paper, then we see that they have a true understanding of the math. Now, you need to know, I know I taught a lot with manipulatives, and I know that my students that were honor students, they didn't like using manipulatives. And you know why? Because a lot of them didn't have that true understanding of the math. They really had a good rote understanding of the symbolic. And so when I would talk to my honor students, and I still remember one of them very clearly now, and actually I see him, he's a lawyer today. And he says to me, I still remember the day you showed me the outcome where it says I should understand things concretely, pictorially, symbolically to get a really good to get a 4 or an A in math. And when you said, so Dan, if you're only going to do the symbolic and just show me the symbolic, it tells me that you don't actually understand the concrete or the pictorial. And he said, and that's when I really realized I got to get down to work to understand this, because he goes, you're right, I had no idea how to do things concretely. And he said, and I really had a hard time when something was on a worksheet or on the test that was just a pictorial and I had to imagine how I moved that around. He said I couldn't do it, but boy, he was, you're right, I was awesome at the symbolic. So top 5 reasons for using manipulatives in the classroom. This is a great little visual that I found. So it's in our slides that I will give you at the end of today's session. And it is from Tammy Jones. Top reason number 1, it will provide a bridge between the concrete and abstract levels of many math topics. So it is something that is really needed to provide that bridge for understanding. They can serve as models that support what students are thinking about, what they remember, and also how to communicate about the math that they are studying. She also said manipulatives provide another representation for the math. So if we're only teaching things symbolically, really kids do not really truly get a stronger understanding. Neither do we as adults. And please know, you don't have to know all of this. You don't need to be like the know-it-all. You don't have to be the keeper of all the information. I will never forget when kids were doing things with manipulatives and I in the classroom was having these aha moments and going, I never even thought of that. When I was putting together my lesson, I had a way that I wanted them to think. Whereas when they were doing it, and then when they were telling me about their understanding, I was having these like, never thought of that, never thought of it that way. And so please know that it is okay not to know. And please know that a lot of the understanding will come out from the discussions that you have in the classroom. I do have to tell you another story also about them. Actually, I'll tell you after this part. They also support student engagement and differentiation. And so I find that students are more engaged also. But it's not an easy thing to jump into. And if you've never used manipulatives in a classroom, or like, for example, if you're going to be teaching grade 6 for the first time, and you're going to be using some manipulatives that you've never touched before, you need to establish rules in your classroom first about the reuse of manipulatives. You need to set your expectations how to do this. I will never forget when I went to a session, and it was a time that I went to a session at ERLC, and it was about manipulative use. And what we were learning was how to use geoboards with elastics. And we were doing area and perimeter. And I came back to my classroom. I was so excited because the session was on the Friday. I set up my lesson for Monday where I was going to be using the geoboards and the elastics. I went to school on the weekend. I found these geoboards. I found the elastics. Some of them were already old. And so when you were pulling them, they were like snapping and breaking. So I knew I had to go get new elastics. I actually set up my classroom in a way because my classroom was a very traditional row on row. And I went and I thought, nope, that's it. I put my tables into these beautiful shapes. I even made my groupings and I put them on the board, and I was so excited. And on Sunday afternoon, I was there just making sure everything was all done. And my principal walked in and he said, "What are you doing? Ilana, you teach math." And I said, "I know, but I went to a session where they were talking about manipulatives, and I'm going to be doing this for a perimeter and area right now in measurement. I'm so excited." And I was telling him all about it. And he goes, "That sounds like a really exciting lesson." And he said, "I like, good luck with it." And I said, "Thanks." I said, "Why don't you come by and check it out after? Like, I'll be doing like it at this and this time." And he's like, "I will, I'll stop by." And so the kids walked in, and the first thing that happened, I remember faces at the door, like looking around, this confused, like, what is going on? Like, "Mrs. Seletsky, what are we doing?" And I'm like, "Look on the board," or it was actually on the white screen. I said, "Look on the screen, find the table that you're sitting at." And so they were coming in and they're looking around and they're finding their table. And then they come down and they find these beautiful elastics on their table. And the next thing you know is they're stretching them, they're pulling them, they're snapping them on each other. They're snapping them like these elastics are flying around my classroom. And of course, I lost it. I lost my composition. I lost my train of thought. And I thought, this is ridiculous. And I just stopped, put a hold on it. That's it. It was supposed to be a fun lesson today, and you guys just blew it. And I made them put everything away and put those chairs and tables back in rows, and the lesson was over. And I was just going to show them how to do it. And I was just going to show them on the screen because I even had like, I was so disappointed. And in walks Garrett. And he says, "Where's the lesson?" And I said, like, "You know what, Garrett?" And I said, "Mr. Garrett, these guys don't get it. They do not, they're too immature to use elastics. So we're not going to do it." And then I came to him at noon and I says, "I'm so upset. Like, I spent majority of my weekend getting this lesson ready, and like they blew it." And he looked at me and he said, "So have you trained them to use manipulatives? Did you ever give them time to play with those manipulatives?" And I said, "No." And he says, "They're kids." And he says, "Actually, they're humans. Put those geo boards and elastics on a table at the staff meeting. You're going to see exactly the same thing happen. If it's something that's new to the kids, if it's something new to a human, we play first." And I thought, oh my gosh, he's right. And I had another math class after lunch. And when those kids came in, there was no manipulatives on the table except for the geo board, no elastics. And I explained to them that we're going to be using these geo boards. And so I let them pick up the geo board. I let them look at it and they asked questions. And then I gave them elastics. But before I gave them the elastics, I set the rules out. I said, "This is not a toy. This is not a weapon. This is something that we need to use to help us understand the math." And what a difference. What a difference. We had this lesson go, and I can tell you that that class learned way more about area and perimeter that day than the class in the morning where I showed them how to figure out area and perimeter. Manipulatives also give students ownership of their learning. And I'll tell you that that ownership was very evident in my afternoon math class. There was no question about it. So please Don't just assume. Don't make the same mistake that I did. Don't assume that they know. You need to set your rules. You need to set your expectations for the use of manipulatives. Because I can tell you, over the time and over my years of using manipulatives were respected in my classroom. They would drop pieces on the floor because pieces fall. They would pick them up. They would put them away in the right areas. They were not mixed up anymore. Kids really understood that they were tools. And I have to tell you that when we got to exam time or unit exams, I had the manipulatives out because sometimes kids would need them to give them support in what to do for that question. Sometimes kids had to resort back to the concrete, and that's fine. And it was fine, and they used them. Some kids didn't. Some kids got to the point where they could do it completely 100% with symbolically, but some kids still needed the concrete. So I allowed them to use it. Okay, going back to this scope and sequence. This is a scope and sequence for fractions. And as you see, it's all highlighted, meaning that the outcomes for fractions are new in all grades from grade 1 to 6. They have all shifted downwards from the grades previous. So everyone is learning something new in fractions. For example, Jackie, correct me if I'm wrong, but were you and I not scared over 2 years ago when we saw what? Kids are going to be learning fractions in grade 1 and 2? Like,
Yeah.
This is ridiculous. They can't do that.
Yeah, but they always share. Everybody shares. Kids in kindergarten, grade 1, they share things that you have one whole or one set, and they share that set. So in the end, when we started thinking about it, we're like, oh yeah, they actually do indirectly work with fractions.
But we've never put the academic language to that. And so then what happens is kids have these misconceptions. And for example, in grade 1, what they're learning in grade 1 is 1/2. And when Jackie said they learn how to share, and we do sharing, one of the things that the research has found, and it's very, very loud and clear, is that we often hear kids in the higher grades think that half means that you have divided something into 2 parts. Well, that's almost right, but it has to be 2 equal parts. And so we often hear older kids say, you can have the bigger half. Like, what do you mean the bigger half? Like, aren't halves both the same size? And so that's what we really want to establish in grade 1, is that when we're talking about halves, they have to be 2 equal groups. And in grade 2, we get to unit fractions, which are limited to 10 or fewer equal parts. So what we're talking about here in grade 2 is 1/2, 1/3, 1/4, 1/5, 1/6, or we can count by units. We can say we have 1/5, 2 1/5, 3 1/5, 4 1/5, 5 1/5. And then they get to see that, oh, when I say 2 1/5, that's the same as 2/5, or 3/5, or 4/5. And then when I have 5/5, I actually have a whole. And so are you telling me that kids in grade 2 can't do that? Of course they can. And we're seeing it happen last year. Kids were actually doing it. But yeah, teachers had to do that bridge because they never did in grade 1 before the 1/2. And so that had to happen. But things have to be age appropriate too. In grade 3, we talk about equivalent fractions. And so now we go from those unit fractions up to denominators of 12, and we relate them. So for things like, kids can see if I have something like 2/5, that's the same thing as 4/10. Because if using manipulatives, we can see that they're the same size. And so that grade 3 is a struggle, and because they had a lot of bridging to do in the first place. So kids that are coming into grade 4, we want them to already know that, but I'll tell you, they don't necessarily know that. So grade 4, where you're going to be doing equivalent fractions, creating by partitioning equal parts of a fraction the same way, and that's where they're going to be doing recognizing simple forms. Decimal fractions, converting decimals to a fraction and fractions to decimal. And those decimal fractions, which I've got some slides on that later, is when the denominator is a multiple of 10. In grade 5, we do fractions greater than 1. That's the first time that we're talking about 1 and a half, 1 and 4/5, 2 and a half. So then in grade 6, we start converting those fractions to decimals and converting decimals to fractions. And so we really want to make sure that, I'm just reading something. So when we are teaching this in grade 4, 5, and 6, we want to make sure that we are moving at a rate where the kids are ready to move it. So then here is the general progression of fractions in the new curriculum. It's exactly like this, but this is just the highlight. This is actually the progression of fractions in the curriculum. And also in grade 6, the other thing that we start doing, in grade 4, we simplify fractions. And in grade 5, we start to add and subtract fractions with a common denominator. And in grade 6, we add and subtract fractions. Now, I've got to tell you, if we're using manipulatives, those topics become so easy to do. And then we also, we start doing fractions, percents, and decimals in grade 4. We relate fractions, decimals, ratios, and percentages in grade 5. And in grade 6, we multiply a fraction by a natural number. So if we're doing that using manipulatives, you will see how easy it actually is. But saying, yes, Tracy, I will be giving you these slides here. And so these progressions and the scope, yes, and the scope and sequence also does that. So let's get on with the show here. Grade 4, now on that scope and sequence, I basically just gave you a quick overview. But if you go to your cusps, you will see how we are to teach this. Now, in our past curriculum, all we saw was kids will learn to do it concretely, pictorially, and symbolically. Now, it is broken down into our cusps, which is really an in-depth, how do we do this? How do we teach this concept? So, for example, equivalent fractions. How can I do this with in my grade? Now, remember, a lot of these words, like Tammy said yesterday, the verbs like model, determine, relate, identify, simplify, express, compare, those are in your skills and procedures, whereas the knowledge and understanding will also give you the nouns. Equivalent fraction, what does that mean? And partitioning a fraction, simplifying a fraction. So if any of these words are something that you're not quite sure of, Tammy's document is like one that you really want to use, and especially with those visuals. The again, these slides will be in your slides that are being shared at the end of today. So again, interpreting in grade 5, where they're doing improper fractions and they're adding and subtracting fractions with common denominators. And then in grade 6, we're relating fractions to quotients, but something that has to really come out loud and clear is the fact from grade 4, we talk about decimal fractions. And so decimal fractions, again, are any fraction that have a denominator of 10. And so when we have a denominator of 10 and we say it properly, which I'll show you shortly, it really does start to make a lot more sense. Okay, and then in grade 6, we also add and subtract fractions with denominators up to 100. Now, this adding and subtracting fractions is from grade 7. And so I know Tracy is sitting here because Tracy actually teaches grade 7, 8, 9. And so Tracy, this, you can see a lot of our grade 7 math in grade 6, but you can also see that foundation being built all the way from grade 1. There's no question about it. And honestly, when we look at this, if done properly, if done slowly, when those kids are actually into junior high, they should have that strong foundation of this, and we shouldn't have to reteach everything. Did you know the number 1 unit that is retaught every single year in school is fractions? We go all the way back every year to what is a fraction, that it's a part of a whole, that it's equal parts of a whole. And why do we do that? Because one of the things is we ourselves are not 100% sure of what is a fraction. And we ourselves, I had this huge wake up moment. I can't remember if it was last year or the year before. I went to a session. I'm just trying to see if I have my book up here. I don't, but if anyone wants to have an awesome book, it is put out by Pearson, and it's the fraction book. Jackie, if you remember the name, that would be great. It is, and if you ever see anyone doing a session on these fractions, like, it is amazing. But the aha moment was this. How many of you will say 4/5 when you're talking about 4/5? Or 7/9 when you're talking 7/9? Well, these authors, these researchers that wrote this book said, stop doing that. And I'm thinking to myself, I do that all the time. So for example, when we say 4/5 for 4/5, do you say 4 in front of 5 for 45? Do you say 5 behind 4 for 45? No, we don't. When we're speaking whole numbers, we speak, we say the number correctly. But something happens when we get to fractions and decimals. We speak in a positional language. And when we speak in a positional language, we're not giving any value to those numbers. So for example, when I say 7/9, a child should think of ninths. And how many of those ninths do I have? I have 7 of them, 7/9. I am missing 2/9. They should be able to picture that. How can they picture that? Well, they picture it because they've used manipulatives that can do 9, they can show 9, and they can actually visualize what 7/9 is. Now, when I say the word 7/9, what do you visualize? You visualize 7/9. No value to that digit whatsoever. Okay, I'm just gonna, let me just look if I have, I don't know where I put it. I use it. No. Okay, when I find it, I will make sure that I do add it to the slides. I will make sure I do add it to the slides so that if you wanted to get that book, because honestly, I think it was my best book that I have read in the last 2 years. Carrie has a question or something to add. Go ahead, Carrie.
What I did was I put a link in the chat asking if that was the fractions book you were referring to. And
Yes.
Jack, yes, it was. So it's there. They can open it and look on Pearson. It is an amazing resource. Yeah.
Isn't it, Carrie?
Yeah.
And Carrie is a math consultant for Edmonton Public Schools. I've known Carrie for I don't know how many years.
2 years.
Yeah, a few years. Honestly, this book was my like a turning point for me in teaching fractions. And it was like when I do present my workshops on fractions, I make sure that I use the academic language properly now, and especially say I make sure I work really hard on trying to say fractions correctly, because all my life as a teacher I was saying a lot of them incorrectly. I often will say a quarter for 1/4, whereas a lot of students don't understand a quarter. When I say the word quarter, a lot of them think of that 25-cent piece because they have experience with that 25-cent piece, so they think that. But when we're talking fractions, we talk about quarters. So when we talk about a quarter, and we also talk about a quarter of a dollar, that in the later grades, I cannot believe how many kids said to me, oh my God, I had no idea that that's why the quarter was called a quarter, because it was a quarter of a dollar. Like these aha moments in kids too. Okay, so today what we're going to start on is working with fraction blocks, also called pattern blocks. Okay, so there's different pattern blocks that you can use. These are the ones that we are going to use today. Now, for many years, when I was using these pattern blocks, I was using just the yellow as the whole. And I compared everything to the yellow. And so the red trapezoid was half of the hexagon. The green triangle was 1/6 of the hexagon. What is this called again, Jackie? The blue.
The rhombus.
The rhombus. All of a sudden, sorry, I'm having this brain fog. The rhombus is 1/3 of the yellow. Go ahead, Carrie.
The tan colored one is a rhombus. Don't we call the blue one a parallelogram?
Oh, yes. Okay.
Between...
Yeah, we can call it a parallelogram. But if I'm only using it here, it's also a rhombus.
It is a rhombus.
But yes, but I'm only going to use these 4. Yes, there are other shapes that are in there. There's the square, but when we are using those, we have to be very careful to make sure that they are all relative to each other, and that they fit together. So what we're going to do is we are going to break into a breakout rooms right away. And I really hope that when we go into the breakout rooms, that you will actually go into the breakout room, put on your camera, talk to the people in your group. Totally, we understand if you don't go into the breakout room. I know that there's some people that just say, oh, I don't want to do this. I'm not going in. I just want to sit back and watch. That's fine too. But I really hope that you will take the opportunity just to share some of your thoughts with your colleagues that are here. Introduce yourself. Now I'm going to show you what's going to happen is you will go to a breakout room that looks like this. Your breakout room, if you've never been in a breakout room in Zoom, what happens is we will ask you to go to a room. So you'll have to see what number your room is. Once you get to the breakout room. I'm going to give you these slides. And then when you go, find the breakout room with your number. So for example, people in breakout room 1 would go to this one here. People in breakout room, and I tried to make the breakout room like a bright color. Breakout room 6, you would use these slides. Breakout all the way to, I have so many. So there's breakout room 18. And we won't need this many. So I'm going to go all the way to breakout room 24 because I know I don't need these slides. And what's going to happen is this. You get to your first slide, and the first slide has been already, all the slides tell you what the 1 is. So in this case, the 1 is the yellow hexagon. So if the yellow hexagon is 1, what is the red trapezoid? Well, you just go into here and you would type in the number. So this is a half, but you need to prove to me that it's a half. And so what you do is you just click on the top and you drag this down and you can put it on top and compare. You could also take the other one, turn it, and show that this, if I move up, I can make this the half. Or I can just keep these 2 separate so that I can see that 2 of these make 1 of those. If this is a half, what is this? Proving it, I can say that it is a third. Okay, and once I can prove it, I don't have to take all 3 parts. I can say, okay, obviously if I move this one down, this will be, but I can do that. And then with this, I would say this would be a 6th. So the first slide is basically for you to play around to show so that you can move these. Yes, I am going to be giving you lots of different virtual manipulatives that you can use. Mathagon is a fantastic one. Toy Theater. Pearson has come out with an awesome set of virtual manipulatives that everyone can use. There's so many, but because we're working in a virtual environment today, and I want to see what people are working with, I made the slides for everyone to use. The second slide is the red is the 1. So if the red's the 1, what is the hexagon? What is the blue rhombus? And what is the green triangle? The third slide, the green triangle is the 1. So if the green triangle is the 1, what's the blue? What's the red? What is the green? In the slide number 4, the blue is the 1. If the blue is the 1, please name the other pieces. And then once you finish those 4, you'll go to the 5th slide. The 5th slide is this. The entire picture is 1. The entire picture is 1. So if that is 1, if that's the whole, what fraction of the whole is the yellow hexagon? What fraction of the whole is the green triangle? One of the green triangles. What fraction of the whole is one of the blue rhombuses? What fraction of the whole is the red piece? And then what you can do is also challenge yourselves and say, well, what fraction of the whole is green? So I can just write down here, I can go up here, I can put a text box, and I can say the yellow is, the yellow is, the green. So now you can see I am not saying the green triangle is whatever fraction. I'm asking what fraction of the whole is green. And what we'll get when we get back, we'll talk about why that is important. And actually, because I've done this on this slide, I'll just go into everyone's slides and make sure that it's in there. Or you can do it yourself, it doesn't matter. So it is 9:16. We're gonna break, are there any questions before we go to our breakout rooms? How many people did we lose when we said we were going to do breakout rooms?
No, just like I think one. I was watching the numbers. It was good.
Awesome. Okay, so any questions?
How long do you want me to set the breakout rooms, Yolanda?
I think 10 minutes, and then we'll see where people are at, and we might have to add. Well, why don't we set it for 15 if we need the extra time, but if not, we can break it off at 10 minutes. Okay?
Yep, sounds good. I'll give everybody the link to
Yes,
the
please.
slides in the chat, and just please make sure that you open this link up before you go into the breakout rooms, just so that you have it, because once you move out of the breakout rooms, you'll lose this this component. So just make sure everybody clicks on it, or somebody in your groups has it, that you guys can work on it together.
Okay, we've got 16 people, 8:20.
Yep. So I'm gonna I'll open up all the rooms.
Let's just wait a minute, because we're only at half of the people in the slides.
Okay.
Yeah, we've only got half of the people. Oh, 30. Okay, so what you need to do is you need to go to your chat. You need to click on the link, click on the hyperlink to get you to the slides. And then in a minute, we will, you'll get an invitation to a breakout room. It'll tell you what breakout room you're going into, which will tell you which slides, 5 slides you have to use.
Yeah, so if you're in room number 1, that everyone's working on room 1 together. So you guys are working together. You don't take each slide individually, introduce yourselves, and then work together on it. Okay, I'm going to open up all the rooms.
Michelle says she wants to start. Get going, Ilana. Move on the show. And Jackie, maybe we can pause the recording for now. Okay. Welcome back, everybody. How did that go? How did that go? You can put it in the chat. What Carol says that was fun. We had people with computer issues and trouble, and went fun. Great. Okay. I'm glad to hear that. And were there anyone where their brain was being twisted because this was a different way of thinking?
Yeah, I just
Different
wanted to add,
viewpoints.
Milana, this was a great way to see, have people, you can see in the chat, some people, it was nice to meet other people, because, you know, we've been with some of these people for 4 days, so it was nice to have the breakout room for them to meet other people. And what's pretty cool is we can see as you guys are working, I love the way Yolanda set this up on Google Slides, because you can see how you guys are interacting. And what's so cool is when kids have the concrete experience like this in front of them, where they can fit things on top and move things and slide things as well, it's pretty cool to see their reactions as well as teachers' reactions.
And, you know, I want to address 2 people, and I want 2 of these people to come on to, if you don't mind. There's KH Godman or Juliet Olivieri. Both had basically the same thing, said, good to see help us understand how students approach these tasks from different perspectives. So, and then someone else said, yeah, great to see the different viewpoints. So here's my question. What are the different viewpoints? What did you see? What were the different, what is the thinking?
Can you hear me?
Yes, please.
Yeah, so we were looking at some of the slides that we weren't sure if we were comparing the right things. If we were looking for numerators or denominators, if we were looking at it on a linear way or not. So we were getting a bit confused. Like sometimes we're agreeing and then we go to another slide and then we compare it and say, oh, that's not right. We think the numerators on top of the denominators larger than the numerator. Like we were getting a bit confused.
Ah, okay. So you know what? I'm going to be very honest with you. When I first started working with pattern blocks, that was one of my hardest issues because I always compared everything to the yellow, to the hexagon. And that was easy because the hexagon is the largest piece. And so I did have a discussion in another group. Someone asked me, why is this 1/1? Like, why is it 1/1? Why, like, what is that? Does someone want to give me their explanation why a fraction, a whole, is 1? Like, positionally, why is every whole a 1/1? Carrie, can you help me with that one? Juliet, do you want to? Is Carrie here still? Carrie, maybe.
I always just, sorry,
Okay.
it's Juliet. Oh, I'm sorry.
Okay,
I wasn't
go,
sure who you were talking to.
Carrie, Carrie. Carrie Faber. 1 part of 1. Yeah, one part of 1. What else, Carrie?
Well, there's the equivalency. So you've got one whole is equal to another one whole. You're not talking about a part in relation to a whole. Other than explaining it that way, you'd have to give me time to think about that.
Okay. Yeah, and that was a really good question. Someone asked me, why is it? And my first reaction is it is one whole. So the 1 means I have one whole, so 1/1. Or obviously, if I had 4/4, that would be 4 wholes. No, it wouldn't be 4 wholes. It would be 4/4, which is 4 parts of 4 parts. Jack, 4 parts of 4 wholes? No, 4.
Johanna, it's Juliet.
Okay, Juliet.
So when I was teaching this past year here, I always try to like make it real life for the kids. So I'll say to them, like, if you had a test that was 1 mark out of 1 mark and you got 1 out of 1, you got the whole test correct. Or if you had a test that was out of 100 and you got 100 marks, you got the whole test correct.
I like that. I like that comparison. Okay, so some people have asked me, can you just go through the slides? And I will. So here is, this one was the whole, which means if I'm comparing this one to the, if I'm comparing the yellow, I can see that the yellow, look at that, is 2 wholes. So this would be 2 wholes. If this is 1 whole, then what is this of the whole? Well, this was interesting because my easiest thing would be well, then what is this? What's missing? What is missing from when I cover that red, when I cover the whole? When I cover the whole, what is missing? Well, it is this piece here. And what is this piece? This is 1. I need 3 of them. So it's 1/3 of the whole. Meaning, what do I have here? I have, why did you just do that? Okay, I have 3 of these. I mean, I have 2 of those, not 3 of those. I have 2 of these. So that means I have 2/3. Because this is my unit fraction, 1/3. How many of those unit fractions cover the red? 2 of them, 2/3. And that's why in grade, I can't remember, we do, in grade 2, when we do unit fractions, that is really important. 1/3, 1/2, like the unit fraction. So how many unit fractions? I have 1/3 here, so I have 2/3 here. The next one, if this is 1, well, that was easy. Here, I have 2 holes. Here I have 3 holes. Here I have 6 holes. Make sense? Then here I have, this is 1. So how many of these do I have to use to cover that? Well, I would have a half. The green is half of the blue.
And I'd like to add, Yolanda, just getting kids to say more than 1 or less than 1, like before they start. So when you're sliding that green one, if the hole is the blue one, would the green one be more than that hole or less than that hole? Will it cover more area or less than 1 whole area? And just to get in their minds, because students get confused either from 2/1 versus 1/2. And so there's no way that with that green one, the green triangle, that I would have more than 1 hole, because when I slide it over, it's only fitting half of that rhombus or that parallelogram. And so I think that benchmarking of more than 1 hole, less than 1 hole, more than 1/2, less than 1/2 is a real big conversation that also has to be had before students start moving these components around.
And you know what? If I was to do this presentation again, I might do this. Oops. Hold on a second. And make sure that this line, oops, that people know that these are fractions. And again, I caution people, don't use positional language. This is not 1/2, because that 1/2 has no value to it. So what that is, it is half. It is half of this. So then using Jackie's rationale, when I get to the red, is this red larger than the blue or smaller than the blue? If it's larger, then we know it's more than the blue. But I can compare the two by doing this, and I can see that the red is larger. By how much? Well, I can see that that red is 3 of these, right? 3 units. So I can see I have 3 halves. So I can see that this is 3 halves. And that means, again, is this larger than this? More than or less than that? I know that that numerator has to be larger than my denominator. And in this case, that yellow is 3 holes. It's 3 of these. And so time-wise, this one here, I'm not going to be able to get into this, but great discussion. And so unfortunately that, Juliet, you had another question, or do you want to add?
I think that was from before, Yolanda.
Yeah,
Oh,
sorry
okay.
about that, ladies. I just forgot to put my hand down.
Okay. So, we were going to use Cuisenaire rods. I personally love the Cuisenaire rod because there's just so much more that you can do with the Cuisenaire rod. Whereas with that other one, those are basically the only fractions that I could come up with, unless I went into making designs and saying, now what fraction of the whole, if this is my whole, then what fraction of the whole is yellow? Well, the bottom line is, if this is my whole, how many yellows will I need to fill the hole? And I would need 3 of them. So the yellow would be 1/3 of the whole. So Cuisenaire rods, on the other hand, are linear models of fractions. And what we do is we assign fraction names to the rod. So for example, with these, and I'm just going to give you the, actually, I'm not going to do that right now because time-wise, we're not going to make it because there are a few other things I need to get to. But you can move these on the screen and you can see that you can break them down into unit fractions. So if the green is the whole, then that means that this unit fraction is 1/6 of the whole. I need 6 of them to make the whole. The red is 1/3 of the whole. Whereas if I go back and I say, this is my whole, then this becomes 1/10 of the whole. And I can also, this is the Pearson model, and I can set the whole and say that's the whole. So that's 1. That means that that's 1/10. And if that's 1/10, this is 1/5 because I need 5 of them to make the whole. But I can also see, I can also take this into equivalent fractions and say, I need 2/10. And that unit fraction business is so important. I need 2 1/10 to equal 1/5. So there's a lot more you can do with these. And I can also say that this is now 2/5. And I can say, I can prove that by saying that this is equal to 2 1/5. Okay. Unfortunately, got to move along. Decimal fractions. Again, this is where our language is so important. A decimal fraction is a fraction where the denominator has a power of 10. It is either over 10, 100, 1,000, etc. And you can write decimal fractions as just, if you're saying them correctly, you should be able to note, I can say this and I can write it as a fraction or a decimal without even thinking, because our positional language that we are used to, because a lot of us were taught using positional language. So a lot of them we would think as 53 over 100. And then the decimal positional language is 0.53. Notice that both of those ways that I said it were positional. They do not have any value whatsoever. But if I, as a teacher, start saying my numbers correctly, 53 hundredths, 53 hundredths, I can write as a decimal or as a fraction immediately. So what are they? Very simple. 1/10 in words is 1/10, but as a decimal, it is written as 0.1. But that, like, again, when I go back to grade 1 and I'm writing 45, I might tell the student that it's 4/5, but I don't, for the rest of my life, say 4/5 or 4 in front of 5. I say 45. And so once we teach kids to say these words, please let's say the words, let's say it properly once we say these numbers, because decimals and fractions are numbers. So decimal, the 10th is 1/10, the 100th is 100th, and the 1000th can be written as 0.001 or 1/1000. So now think about the fact, if I was to say 3/10. Well, how do I write 3/10 as a decimal or as a fraction? How do I write 300ths as a decimal or as a fraction? I don't have to think about the fact that it's 0.03. I know that it's 300ths because I have 3 100ths. So though, and we can use place value blocks to help us with that. And then when we get into multiplying decimals, yeah, Tracy, relating it to the place value chart as well is important, except for I have a question when we get to that. If I have the number, for example, I'm just going to say a number and think about this number that I'm saying, 4 5/10. 4 5/10. How would I write that as a decimal? Anyone, if you can just put it into the chat. Okay, so what I have is, yep, great, 4 5/10. So here's my question. Listen to how I say this question, please. I'm going to say, what digit is in the tenths? Yeah, the 5 is in the tenths. But now listen carefully. How many tenths do I have? Yeah, I have 45 tenths. And so when I say I'm using the place value chart, careful how you ask the question. What digit is in the tenths is different from how many tenths do I have? Because let's just go back to the whole number. What if I said the digit 45? How do you write 45? Anyone? Yeah. 45. 4 in front of 5, 5 behind 4. What digit is in the ones place? 5. How many ones do I have? I have 45 ones. I don't just have 5 ones, I have 45 ones. Think of, what if I had 45 cents? How many pennies do I have? I have 45 pennies. Okay, but how many tens do I have? Yeah, I only have 4 tens. 4 tens and 5 ones will make 45. And that comes from grade 1. How many ways can you make 45? And so how many ways can you make 4 and 5 tenths? Well, you can make it one way. You can have 4 wholes and 5 tenths of a whole, or you can have 45 tenths, and that will still be 45 of 4 and 5 tenths. Okay, I cannot believe that this time, I just wanted to tell you, we have a lot of upcoming sessions starting in September. We have support for new teachers. Anybody here that is new, that is going to be a new teacher for grade 4 to 6, like that. We're not talking about teachers like you, Larissa, that have been teaching for a long time, but teaching your grade for the first time. We're talking about new teachers here straight from university or whatever. But if you are new to grade 4, you would want to go to the Unpacking the New Math Curriculum for grade 4. Or if you're teaching grade 4, we're all teaching this for the first time. So Betty will be unpacking the grade 4 curriculum, the grade 5 curriculum, the grade 6 curriculum in different sessions. And she'll also be doing a grade 5-6 new curriculum session. If you're teaching a split, that might be something that you consider. I know that a number of school districts are using the Elk Island math assessment that we made last year, and we're using it in the beginning of the year. Myself and Heather will be doing a session on September 13th, one in the morning, one in the afternoon, about if you did the or you're doing the thing, what are you going to do with the results? How do you move forward with the results? September 14th and 14th is unpacking the new curriculum. September 20th is unpacking the new math curriculum. September 25th is planning actions. This is Tammy is doing a grade 4 to 6 session with her document, the one that she did on Monday, Tuesday or Wednesday. So she's also doing one just for grade 4s about the verbs and the nouns, the action words in grade 4. People were asking about gizmos. There are 3 gizmo sessions coming up. One on September 26th for grade 6s, one on September 28th for grade 5s, one on October 3rd for grade 4s. Then Tammy's session for grade 5. There's mathology. If anyone wants to see a resource resource for grade 4 to 6 and how you can use your mathology for grade 4 to 6. Lots of session comes up. Janice, yes, the Elk Island resource is available to everyone. What school district are you from, Janice? The reason I'm asking is, yeah, the Rethinking Fraction book, I'm not sure if you can get it on Amazon yet. I'm not sure. New Horizons. You know what, Janice? I think New Horizons actually already has access to it. But I will check into it and let you know in an email. Yeah, we did for the last few years, we were working on an assessment to use for grades 1 to 7 in thing. If you want more information on it, I could do that. Because I'm running out of time, but a lot of districts will be using it this year. And but you have to know, if you are using it in grade 4 to 6, your kids are not going to do very well at all, because it is based on the new curriculum. But best part of all is it is based on the progressions in math, the one that Dr. From U of A wrote.
Dr. Lynn McGarvey.
Yeah, Lynn McGarvey. So the assessment that we wrote is best based on the on the progressions in math, which really will help you with, okay, now what do I do with this results? And it'll also give you a good starting point in September in the number strand only on where are my kids at and where can I start? But we do know, we would know. So lots of boards. Star Catholic, yes, Star Catholic is using it. I'm not sure right now. I'm starting to think, because it's already 10 o'clock. I'm sorry. Think about what session topics you would like some support with. I just want to show you, Jackie, you also have a question, so go ahead while I'm doing this.
Yeah, sure. Yolanda, I just wanted to thank you for today. It was awesome. It was interactive, and I've been getting a lot of texts and feedback from people that they've been very appreciative over the 4 days. I just wanted to add as well that John San Giovanni, he has some amazing books on strategies for adding and subtracting whole numbers and fractions and decimals. And he talks about that there's only 5 strategies that we should be using. And he's going to be doing a series for ARPDC. It's not quite up on the website, but I'd love for you to check it out. He's amazing. His books are amazing. And it's really good discussion for you to talk with your staff that you know, sometimes on YouTube, or, you know, you look on Facebook and everybody has these strategies for adding and subtracting numbers or fractions, but he has tried and true strategies that work from whole numbers to decimals to fractions. And so his name's John San Giovanni, and we are just putting up his name on the website. So please take a look at that. It's been a very popular session. I can put that on there, and then maybe we can send an email once that's out to everybody.
My top 5 manipulatives for Division 2: place value blocks, Cuisenaire rods, pattern blocks,
Geoboards,
geoboards, squares.
double-sided counters.
Oh
Yep.
yes, you need double-sided counters for grade 6 for sure. For your, and I would just say double-sided squares would be the best side thing, because when you get to integers, so you need to know, again, session wise, Betty is doing the sessions on really deep understanding of the curriculums. Once she's finished with those topics, like she's going to do a topic on fractions, then I am going to do another topic strictly on teaching those fractions. So I will be using slides again for pattern blocks, but I will definitely be using the Cuisenaire rods more, and really giving doing lessons that you can use grade specific for teaching your concepts. In these slides that I shared with you today, I know people have been telling me I'm not receiving the recordings. So slide 1 is the recording and the passcode for all the slides. I will add the recording to today's session at the end. Here's the links for all the interactive slides that we shared yesterday, today, and Monday, Tuesday, Wednesday. Here are all the slides from the PDFs. There's the slides from today. Here's all the upcoming sessions with links for you if you're interested in going anywhere. But on slides 17 and 18, I really would like you to think about, is there anything in particular that you would like us to offer you? We totally get it. This combined classrooms, someone has already written how to plan, assess, differentiate for split classes. We have already spoken about that, and definitely this is a thought that we are putting in. But on slide 17, 18, 19, if you wanted to add something in here about what you would like to see come up, I'd really appreciate it. I know it's after it. I am sharing with you all of my Wakelets that I use in all of my, for all my files. Please go ahead, click on it, go there. Everything, all my files are in my Wakelets. You don't have to have a Wakelet account. You just can go there. But here's all of the resources that we used for the last 4 days in our session. Please have yourself a great year. All the best to you. If there's any way that we can help you, please reach out to us. Right here on slide 16, in the things that I gave you the names of the people that are in your area. But because we are, if you feel more comfortable contacting myself, Jackie, Betty, or Tammy, and we're not in your area, that's okay. We can always help you out. There's our thing, and the very first one was a link to all the consortiums, so where they are. Thank you, thank you, thank you. Have yourself a great weekend coming up. All the best to you in the school year.